Okay, so today we're going to start talking about what are called trigonometric identities or trig identities. And the word identity just in math means an equation that's true for all the values for which the variable is defined. So it's just an equation where both sides of the equation will always be equal no matter what you plug in for the variable. That's an identity. So they give you an example here that's not a trig identity, it's just an identity. But this is always true. A squared minus b squared will always equal the factors a plus b times a minus b. It's true no matter what you plug in for a and b. If you want to try a few things, you can try a few things. Anything that you could plug in for a and b, that would be true. There's a bunch of identities that connect to the trig functions, and these identities allow you to substitute one function for another one in an expression, which can be useful when you're doing lots of things. And one of the things we're going to use it for is when we're solving more complicated trig equations than what we've been doing. So where some of these come from is from actually something you're already familiar with, the unit circle. With the unit circle, we've already defined all of our trig ratios in terms of x and y. So for example, we know that sine is the y and cosine's the x, and we get the tangent by dividing the y by the x. And cosecant, we flip the y, secant, we flip the x, and cotangent, we divide the x by the y. We also know that the equation for the unit circle, because it's a circle with a radius of 1.
And Mr. Skank, could you please come to Ms. Alstott's office immediately? That is Mr. Thunderberg.
Sorry, I was not going to try to talk over her. So the formula for the equation of a circle is x squared plus y squared equals the radius squared. So for the unit circle, since the radius is 1, 1 squared is just 1. So this is the equation for the unit circle. So all of these relationships we already know, and we can use these to define some of our basic trig identities. There's actually 8 basic ones that you will be responsible for learning. And by learning, I mean memorizing. So you'll actually find it's not so hard because we've actually already done some of this with these. But from these relationships here, we're going to get our trig identities. So let's look at the different identities. So the first one we're going to talk about are the reciprocal identities. Because we know that cosecant is 1 over y, and we know that y is the same as sine, that means that we know that cosecant is 1 over sine. All right? So instead of saying cosecant is 1 over y, we can say that the cosecant is 1 over sine, because sine is y. We can say the same thing about secant. We know secant is normally 1 over x, and x is cosine, so secant is 1 over cosine. And we know that cotangent can be x over y, but it can also be the reciprocal of tangent, right? It's just tangent's y over x, cotangent's x over y, so cotangent's the reciprocal of tangent. So these are what are called the reciprocal identities because it tells you which functions are reciprocals of each other. These are always true. The ratio identities are tangent and cotangent. Tangent we know is y over x. And since y is sine and x is cosine, we can say that tangent is sine over cosine. And cotangent is x over y, and x is cosine, and y is sine, so that means cotangent is cosine over sine. Right? So these are identities. These are things that are always true no matter what theta is. No matter what angle you have, these relationships are always true. You may see these in slightly different forms. For example, they may have these squared. So for example, one of our identities was that tangent is sine over cosine. They may also say that tangent squared is sine squared over cosine squared. Okay. So that's another version of that identity. That would also be true. Same thing with this reciprocal identity. If we square everything, cosecant squared, 1 squared would still be 1, and sine squared, this would still be true. Right, so that's a variation of those that we saw before. All right, and then the last of the basic 8, so we've seen 5 of them, so there's 3 more. They're called Pythagorean identities because they look like the Pythagorean theorem. Something squared plus something squared equals something squared. And they come from the equation of the circle. We set up at the top that the equation for the unit circle is x squared plus y squared equals 1. And we also said that x is cosine and y is sine. So we could say, instead of x squared plus y squared, we could say cosine squared plus sine squared equals 1. All right. So that's the first of the Pythagorean identities, and it comes from the equation of the circle. Now, a couple of variations on this. If you were to go through and divide everything in this equation by cosine squared, then we would get 1 plus sine squared over cosine squared. Sine over cosine's tangent. 1 plus tangent squared. And 1 over cosine is secant, so 1 over cosine squared is secant squared. So if we divide everything in the first Pythagorean identity by cosine squared, we'll get this. 1 plus tangent squared equals secant squared. That's another identity. And the same thing if you were to go through and divide everything by sine squared in this equation. Whoops. If I were to divide everything by sine squared, let me change the color here. Sine squared instead of cosine squared, right? Then this would be cotangent squared. Cosine over sine is cotangent, plus sine squared over sine squared would be 1, equals, and then 1 over sine squared, 1 over sine is cosecant, so 1 over sine squared would be cosecant squared. So these are your 3 Pythagorean identities. So just to kind of summarize real quick, your identities that you have to know are your reciprocal identities. That is that cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent. Your reciprocal identities, that is tangent is sine over cosine, and cotangent is cosine over sine. And then your Pythagorean identities, which is cosine squared plus sine squared equals 1, 1 plus tangent squared equals secant squared, and cotangent squared plus 1 equals cosecant squared. Right? So these are the 8 basic identities that you need to know. And so we're going to be practicing doing some things with these that will hopefully help you remember them. Okay, so let's look at the last little bit here. Last thing that you need to know here about these identities is that each of these can actually be rearranged to form new identities. So for example, this sine squared plus cosine squared, notice that it's already different because we wrote it cosine squared plus sine squared. It's the same thing either way, whichever one comes first because you're adding them. But you could rearrange this like this. You could move the cosine squared over. So you would have this. Or you could move the sine squared over. So you would have this. Or you could change all the signs. So you would have, right? Lots of things that you can do to this identity to create new identities just by moving things around, changing signs, all of that kind of stuff. And you could do that with any of these. So we'll go over some more of that kind of stuff tomorrow in class. So what you're going to be doing with this is trying to simplify other expressions using these identities. All right, so for example, sine of theta times cotangent of theta. We want to simplify this to a single trig function or number. One of the best strategies to use is change everything to sines and cosines. So for example, on this one, we've got sine theta, but then cotangent theta can either be 1 over tangent or it can be cosine over sine. I'm going to change it to cosine over sine because that's the strategy I'm using. I'm changing everything to sines and cosines. Once I do that, I can see the sines will cancel out, and I just get cosine. Right? Let's try the same strategy on this one. I'm going to change everything to sines and cosines. So this first fraction is already sines and cosines, but cosecant I'm going to change to 1 over sine. So now you can see you can cancel. You've got sine squared on the top, sine on the bottom. So that gives me sine over cosine, which is tangent. Right? So I can use my identities to simplify those. Right. Anytime I see squares, I'm going to think Pythagorean identities. And so cosecant squared times 1 minus cosine squared. Remember, cosine squared plus sine squared is 1. So if you subtract cosine squared from both sides, you'll get sine squared equals 1 minus cosine squared. So 1 minus cosine squared is sine squared. Then cosecant is 1 over sine. So now if I change everything to sines and cosines, you can see these cancel and I get 1. Right? Here if I distribute sine times cosecant, cosecant is 1 over sine. So sine times cosecant, I'm doing sine times 1 over sine, minus sine squared. Sine times sine is sine squared. 1 minus sine squared. If you solve this identity for sine squared, if you move the cosine squared, if you move the sine squared over, not solve for sine squared. If you move the sine squared over, you'll get cosine squared. All right, so we'll do some more of these tomorrow in class, and we're kind of running short, and I also realized I didn't put these examples in your notes, so I'm sure you've had to pause the video and write them down. So bring your worksheet back with you, and we will look at the problems on the back tomorrow.